Given the roots of two binary trees, we need to return true if they are the same tree. Two binary trees are considered the same if they have the same structure and all the nodes have the same value. Now, if you haven't already, I would highly recommend you first watch my video on LeetCode number 104, Maximum Depth of Binary Tree. We're going to be using very similar recursive logic, but this time on two trees instead of one. The link is in the description, so please go ahead and watch that first. Okay, now let's look at this solution. The two roots that are given are called P and Q. So let's say the top one is P and the bottom one is Q. We're going to use recursion to perform a depth-first search of the two trees, and at each step, we'll compare P and Q to each other. So this recursive algorithm has three base cases. The first case tests if both P and Q are null, or in Python, it's called none. So if P is none, then Python will treat it as false. That means not P will be true, and the same logic applies to Q. So if both P and Q are none, then both of these statements are true, and that makes the overall if condition true as well. And if that happens, then we'll just return true. This is because if both P and Q are none, then that means we've gone all the way down to the end of a branch, and everything so far has been identical, including the last none. This may be hard to visualize since we haven't actually done the recursion yet, but for now just keep this in mind as the first base case. If that base case wasn't true, then at this point, we know either P or Q or both of them are a node. So next, we'll find out if both of them are a node, or if only one of them is a node. We'll do this by testing the condition if not P or not Q. So if either P or Q are none, then this condition will be true, and will return false immediately. That's because we know that at least one of them is a node. So if the other is none, then they're different from each other, and we return false. If that wasn't true, then at this point, we know that both P and Q are nodes, so we can compare their values. If their values are not equal to each other, then that means the nodes are different, so again, we can return false immediately. If all of these conditions were false, then that means both P and Q are nodes, and their values are also the same. So if this is the case, then we'll need to traverse further down the trees and check the branches below. We'll do this by recursively calling the same function and by first passing in the left nodes of P and Q, then the right nodes. A quick note here. If you're doing this in the LeetCode environment, then your answer will have to be within a class, so you'll have to add self.isSameTree to the function call. But for now, I'll stick to the general solution. In order for this statement to return true, the left subtrees of P and Q must be the same, and so do the right subtrees of P and Q. You'll see how this works in a second, so for now, let's get started with the example. So P and Q are both nodes, so not P and not Q is false. Then let's check the next condition to see if one of them is none. This condition evaluates to false or false, so it's still false. So now that we know that both P and Q are nodes, let's check their values. Both P.val and Q.val are 1, so they are equal to each other, and this condition is false. This means that P and Q are the same, so now let's move on to the next node down the tree. We'll start by checking the left subtree, and we'll do this by recursively calling the function again and passing in P.left and Q.left, which are the left nodes. So let's enter this recursive function call, and I'll leave a green dot here so we know where we left off in the original function, where P and Q are in green. Now we're in the new function call, and P and Q are the nodes in orange. Then we'll do the same thing. Neither P nor Q are none, so the condition not P and not Q is false. The next condition, not P or not Q, is also false for the same reason. And now let's compare their values. Both values are equal to 2, so it's time to go down to the next level. We'll do this the same way by, again, recursively calling the same function and passing in P.left and Q.left. This time I'll put an orange dot, since right now P and Q are colored orange. And now let's go down to the next level, where P and Q become the none value on the very left. Now when we check this condition, not P is true, and not Q is also true. So not P and not Q is true. That means we've reached the end of this branch, and P and Q are equal to each other, so we can return true. Now we'll return to the function where P and Q are the orange nodes, and we'll pick right back up where the orange dot is. Remember, we return true, so this part here is true. Now we need to know if the right branches of P and Q are the same. So let's move on to the next function call, but this time pass in P.right and Q.right. Again, I'll leave an orange dot so we know where we left off, and let's enter the new function. We'll check this first condition, and since P and Q are both none, this is true again, and we'll enter the if block and return true. So now we return to the orange dot, and it has returned true. We're now finally done with the function call where P and Q are in orange, and so this statement evaluates to true and true. So in other words, we'll return true. So now we're going to return to the function where P and Q are the nodes in green, and this part returns true. Then we'll have to do the final recursive call and pass in P.right and Q.right. So let's enter the function, and we see that P and Q are both none again, which makes this condition true. So we'll return true, go back to the green dot, and now this is true. Now we've finished evaluating the final return statement, and this evaluates to true and true. So we'll finish up by returning true, which signals that the two trees are identical to each other, and we're done. Now let's try an example where the two trees are different from each other. Let's use these two trees, and again, P and Q will be the root nodes in green. We'll start the same way by checking each base case. Since both P and Q are not none, this condition is false, and so is this one. The node values are the same, so this is also false, and let's begin the recursive calls. We'll start by passing in P.left and Q.left, and we'll enter the new function. Notice that P is equal to none, but Q is a node. This condition is still false since Q is not none, but let's check this condition. Not P is true since P is none, and even though not Q is false since Q is a node, it doesn't matter because these two statements are linked by an OR. That makes this overall condition true, so we'll return false. Now we go back to the original function, and this will be false. But at this point, we don't even need to do the second recursive call and pass in P.right and Q.right. That's because these two statements are linked by an AND. So in order for this overall statement to be true, both of these must be true. But since we already found the first statement to be false, it doesn't matter what the second one will be. The overall statement will be false either way. So at this point, we can just return false and we are done. The two trees are not the same.